All right. Happy Friday, everybody. Today we're going to be looking at the law of cosines. I see some people still, most have not finished the law of sines as of this evening while I'm making this new video. That's okay. I know it was only a 45-minute class yesterday. So use the time that you got after these notes to go back and work on both the law of sines and the law of cosines. On Tuesday, we're going to do some activities related to this, and then I'll let you know how it's coming with how the upcoming assessment's going to be on this module 9. All right, law of cosines. The law of cosines is used when the law of sines cannot be used to solve a triangle. It might apply. We can use the law of cosines when we're finding the length of a third side when we know the measure of two sides, when we know two sides, and the included angle. Or if we know all three sides and we're looking for what are the angles. So that's a little different. We can't really do that with the law of sines. We can do that with the law of cosines. So if we know all three sides, excuse me, if we know all three sides, we can use the law of cosines to find the missing angle. So the law of cosines states, if triangle ABC has lengths A, B, and C representing the lengths of the sides opposite of their angles that match up, then these three formulas occur. We can use the law of cosines to solve a triangle if we know the measure of two sides and the included angle, which we just said here, or if we know all three sides. First, we're going to look at when we, this is the first way we're going to look at it, when we know SAS, okay, side, angle, side. The angle that's between two of these. So here we know angle C, and we know side A. So this is side A because it's across from A, right? And this is side B because it's across from B. And we're looking for side C, which is that X side there, right? All right, so how do we go about solving that? We're going to use the law of cosines. So we're looking for C, right? Since we're looking for C, that means we're going to use this C squared one. C squared equals A squared plus B squared minus 2AB cosine C. And we're just going to plug that in. So we're looking for C squared. Actually, C squared becomes X squared because X is what we're technically looking for there. It doesn't really matter. We can keep that the same, but I'm going to change it to X squared because X is what we're looking for. That equals 0.9 squared plus 2.9 squared minus 2 times 0.9 times 2.9 times cosine 44 degrees. So X squared equals 9.22 minus 5.22 cosine 44 degrees. That means X is the square root of that. And when we plug that into our calculator, or use our calculator, we end up with that side length of X being about 2.3. Okay, so that's how we use it when we know one of the sides. Now, it all depends on the side we're looking for. In this case, we're looking for the C side. If we're looking for the A side, we're going to be using A squared equals. If we're looking for the B side, we're going to be using B squared equals because we're going to know the other two sides and the included angle. I hope that makes sense. Okay, so they're a little bit different depending on which one it is. Basically, it's just kind of mixed up here, but you got to know these three formulas. We can also use it when we know all three sides of the triangle. Okay, in this case, when we look at this one, we are going to use the law of cosines, and we need to say what is it that we're looking for. We're looking for P, right? P is what we're looking for. So that means we're going to use kind of P squared here. All right, we're going to use P squared equals M squared plus N squared minus 2MN cosine P, because P is what we're using or what we're looking for. So we're going to use the cosine of that at the end, and we're just mixing up the other two letters in there. So remember, this is N, this is P, and over here is M, because those are the sides that are across from the given angle. Okay, so I manipulated the formula. We can manipulate it depending on what it is that we're looking for. So when we got the three sides, we're going to be looking for one of the angles. That's the one that's going to be going to the equal. If it was N that we were looking for, our formula would have changed here, and it would have been N squared equals, the P squared plus M squared minus 2PM cosine N. It all depends on what it is we're looking for. So we're going to go ahead and fill this in. So we know P squared. So what we know the sides now. And what we're looking for is the cosine, the cosine of this x squared here at the end. That's what or x degrees here at the end. So now 9 squared is 81, 5 squared plus 11 squared, that's 146 minus 110. Use your calculator, so 5 squared plus 11 squared is 146. Minus 2 times 5 times 11 is 110 cosine x. All right, so negative, we move the 146 over. That means negative 65 equals negative 110 cosine x. So that means negative 65 divided by negative 110 equals cosine x. So x, that means, since we got the cosine x, we're going to do the cosine negative 1 of negative 65 over negative 110. And that, when we put that in the calculator, comes out to be about 54 degrees. So angle P there would be 54 or 54 degrees. I hope that makes sense there on that one. So those are the two types you're going to have for when we use cosines. The other ones were the law of sines. We're going to use law of cosines when we've got the side angle side, or we've got the side, and we're looking for the angles. So use these notes. Make sure you got these written down. Again, I'm going to be checking the notes on Tuesday. Make sure they're all written out exactly like they are in these videos. All right, now we can use that as well to solve problems. All right. What in the world kind of name is that? I'm reading this for the first time. Inhot. All right, you all think about it. What's that name? We're going to figure it out. Tuesday, I want to know what your idea for that name is. Nihat is golfing and uses a distance measuring tool to determine that the tree box where he is standing is 378 yards from the hole. To avoid a water hazard, Nihat, it bugs me now, turns 32 degrees and hits a shot 261.5 yards up the fairway. Complete the diagram with the correct values. Then find the distance between Nihat's ball and the hole to the nearest yard. Okay, so we're kind of seeing there. We know the measure of two sides of the triangle and the included angle. So we know this side is 378, we know this side's 261, and we know this angle is 32 degrees. That's the one that we're looking for, okay? We're going to use the law of cosine since we know that side, angle, side. So in this case, that x squared is going to equal the one side we know, squared, plus the other side we know, squared, minus 2 times each of those side lengths, cosine that angle that's inside there. So x squared equals, when you use your calculator, 211,266.25 minus 197,694 cosine 32 degrees. So now we're going to take the square root of both of those. And when we do that in our calculator, x comes out to be about 209. So Nihat's ball is about 209 yards away from the hole once it lands there. Hope that makes sense. So that looks just like that one with the side angle side. All right, pause this and try the cell phone tower one. So right now, pause this video, try the cell phone tower one on your own. Remember now that this one is side, side, side. We have all 3 sides. So we're going to be using the law of cosines, but this is going to look a little bit different because we're going to use what we're looking for there thing. All right, so let's take a look here. If you've done it correctly, you should have come up with an answer of x equals 99 degrees. Now, how do we do that? I'm going to write out the first steps here, and then you should be able to work it out from there. But basically, the 2 miles is what's across from that x. So those are the 3 sides we're using. When we do our formula now, we're going to be using 2 squared equals the other 2 squared minus 2 times the first one times the second one cosine x. And then you just work it out from there, just like we just did up here in this other example here. Okay, you're going to end up with that cosine -1 and everything. And when you work that down, you should get to an answer of x equals 99 degrees. Okay, so hopefully that makes sense there with the law of cosines. Now, when solving right triangles, this is the last couple here, the last couple examples you're going to see. We can use sine, cosine, or tangent. When solving any triangle, you can use the law of sines or law of cosines, depending on what information is given. So when we have a right triangle, we can use any of the 3, sine, cosine, or tangent, that we've already learned. When it's not a right triangle, we can only use law of sine or cosine. And again, we're going to use law of cosine when we got that side angle side or side, side, side. We're going to use the law of sines when we have a different one. So look at this example 4 here. So what do they give us? Right? First of all, we need to see if this is even a right triangle, right? So when I look, does the 7 squared plus 8 squared, does that equal 11 squared? No, it does not. So I know this is not a right triangle. All right, so we decide which angle measures we want to find, then we use the law of cosines. All right, so this first one says solve a non-right triangle with the law of cosines, which kind of makes sense. But basically that means we got to find our 3 angles, right? We need to find the 3 angles. So the way we're going to do that is we're going to use our formula, a squared equals b squared plus c squared minus 2bc cosine a. So we're going to look for this first angle measure. We got to find 2 of the angle measures, and then we can subtract from 180 to know the third, right? So here we got 7 squared equals 11 squared plus 8 squared minus 2 times 11 times 8 cosine a. So 49 equals 185 minus 176 cosine A. We move that 185 over. We divide both sides by negative 176. And then we take cosine negative 1. And that gets us the measure of angle A to be about 39 degrees. I'm just going to write below here now. All right, so that found us 1. Now we can use the law of sines. Now that we know this, we can use the law of sines, because we can use the law of sines and cosines, right? So now we can use the law of sines to find angle B. That's probably the easiest way. So I'm just going to do that below here. You might need to move it on the side or whatever, but we can use sine of A over A equals sine of B over B. So sine of A over 7 equals sine of B over 11, because A equals 7, B equals 11. So that means 11 sine A equals 7 sine B. You divide by 7. It's 11 sine A divided by 7 equals sine of B, which means the measure of angle B is sine negative 1 of 11 sine A over 7, which makes the measure of, because we use the inverse sine function, that means the measure of angle B is about 86 degrees. Now, to find the third, measure of angle C is going to be 180 minus 39 minus 86. So the measure of angle C would be about, because we've had to round in there, 55 degrees. So hopefully that makes sense there on that one. Okay, so that was solving a non-right triangle. What about solving a right triangle? Okay, so look at FGH here. Now, we're being told that's a right triangle, right? It says round the measures to the nearest degree and side measures to the nearest tenth. But basically, we've got two angles and one side still defined here. So you got to put all this together, right? But if it's a right triangle, then I just use Pythagorean theorem. I can use Pythagorean theorem. 2 squared plus 3 squared. 2 squared plus 3 squared equals h squared. So 13 equals h squared. Take the square root of both sides. So h is about 3.6. All right, so we found that first side length there. And let's see, now we need to find the measure of angle F. So we're going to use the law of cosines here to do this one, because that's what they want us to do. Solve a right triangle with the law of cosines, right? So we're looking for the measure of angle F, right? So that means we're going to be using the one across from that equaling the other two. So we know then that 2 squared, because that's the side across from angle F, since that's one we're looking for, 2 squared equals 3 squared plus the square root of 13. I'm going to use the square root of 13 here because it's going to be more exact than using the 3.6. Since we found the other side was the square root of 13, it's better to go ahead and use that here. Because when we square that, it's going to come out to be exactly 13 there. 2 times 3 times square root of 13 cosine F. So 4 equals 22 minus 6 square root of 13 cosine F. So negative 18 equals negative 6 square root of 13 cosine F. We divide now. Negative 18 divided by negative 6 square root of 13 is cosine F. So now when we do that measurement there, we end up with the measure of, when we put that in a calculator and do that one, we get that measure of angle F is about 34 degrees. Now, you could have done the other one, right? We could have done the other one. You could have done angle G instead. And when you would have done angle G, you would have got, 180 minus these other ones. So now we just got to do, you would have got 56, right? So we already knew that. But if you'd have used the other law of cosine. But now we just do the measure of angle G, the one we're needing, is 90 minus 34, because I know that the two missing ones have to be 90 degrees, which makes the measure of angle G about 56 degrees. So we found the missing side length and both of the missing angles. I hope that makes sense. Please make sure you got these notes. If you're unsure of one, and I know I went kind of quickly through a couple of these, it's on YouTube here, so rewind it, watch it back, watch me fill it out again. Make sure you see the difference in these three formulas. Basically, they're the exact same formula. It's just the first one is the one across from what you're looking for, okay? So follow along now. I'm going to have you just go right into McGraw. I think I'm going to look for a couple other YouTube videos on law of sine and cosine that are optional. If you want to watch for a little more information, I think there are a couple that I've used before, and I'll put them below it in Canvas, but they will be optional. If you think you got this, you can go out and work. But bring all your work for these that you've done these couple days I've been gone. The law of sines, law of cosines, bring all that work on Tuesday. I will be looking at that. Don't just have the answers, okay? All these require work. All right, have a good rest of the day. Have a good weekend. I will see everybody on Tuesday.